Okay, now let's go ahead into my Kali Linux VM and actually perform a WPA attack. And before exactly going into that, I just want to say that like a real hacker, I'm going to do the attacks completely blindsided, which means I will not have my phone in my hand. I will not exactly touch my phone, because in a real world the hacker will not have physical access to the victim's phone. So I'm not going to touch my phone at all, and I'm just going to do this completely blindsided. Now, before that, I want to say, to do this attack or to perform this attack, you need to have a Wi-Fi adapter that has the capability to do packet injection. Now you can just go ahead and in Amazon and just search for Wi-Fi adapters like Alpha or a generic Athreos which is capable of wireless injection. Alright, so I am using TP-Link 722N version 1.1, which did used to have the packet injection capabilities, and it was pretty cheap. So let's go into the process immediately. Now, as you remember, I was talking about the aircrack-ng package that we are going to use to do these type of attacks. But before that, just let me check that if my device is connected, if my Wi-Fi adapter is connected. So I will just type list USB or ls USB, and you can see Qualcomm Athreos 9271 is connected. So I will just check if my Wi-Fi network is up and running, and to do that the command is iwconfig. So you can see WLAN 0 is up and running, and it's in basically managed mode, but we need to set this in monitor mode. And if you remember, the command for doing that is airmon-ng. But just before jumping right into that, we need to stop some processes which can conflict with the device being in monitor mode. And to do that, the command is same airmon-ng check and kill all the processes that can conflict. So let's just wait for the confirmation, and you can see that WPA supplicant has been stopped. It will not work anymore as a supplicant. And now let's go ahead and start the device into monitor mode. So airmon-ng start WLAN 0. So let's wait for the confirmation, and if we just go to the ifconfig again, you can see that the mode has changed from managed to monitor. So my device is up and running in monitor mode now. And now let's go and sniff the air around me. In this case, I'm going to use my actual Wi-Fi router here. So let's go ahead and type aerodump ng, and then my interface name, which is going to be WLAN 0 mon. Right, because you can see that is in fact the interface that is the monitor mode interface, right? So let's hit enter and see. Now some of these terms here that I want to say to you is that the BSSID actually means the base service set identifier, which is going to be the MAC address. ESSID is going to be the extended service set identifier, when basically there are two access points on the same device. We need ESSID specifically. Now auth or authorization way, the authorization mode is pre-shared key, because there is another way for WPA2, and that is going to be WPA2 Enterprise, where there is a separate AAA server, but we are not going to be talking about that in this tutorial. The cipher that is used in both of my devices is CCMP, or counter mode with cipher blockchain MAC protocol, and the encryption used is WPA2, which I said is the use of pairwise master key, pairwise transient key, message integrity code, etc. Now this part of this tool is what we call the devices which are mainly unassociated or associated. So the station is this one, which is probably my phone, I don't know, like a real hacker. So let's just go ahead and stop this, because we got what we need. We got the BSSID, we got the ESSID, and everything that we need. So we are going to run the attack on my guest network deceiver. So let's just check. Okay, so what I'm going to do is run aerodump ng. Now just let me say one thing, that when my device is already connected to my Wi-Fi router, so no handshaking process is going on right now. They're just simply transferring data, alright? Because for us to capture a handshake, we actually need the handshake process or the connecting process for those two devices going on when we are actually sniffing. But we were not actually sniffing when the two devices connected, because my phone is already connected to the router for like 2 or 3 hours at least. So we are going to do the same thing like a real hacker would. So aerodump ng, now this is the command, --, base service set identifier, and we are going to give the MAC address of the target access point. So in this case it's deceiver, so this is going to be the target MAC address, and I'm just going to paste that here. Now what we need is the channel. The channel that my device, my phone and my router is communicating is 8. We are going to write the files. Okay, not just we are going to write the files right now. We are doing this to see the MAC address of my phone that is connected to it. Okay, so I'm just not going to write it right now. So channel 8 and my interface, which is WLAN 0 man. So if we copy paste that, let me just get the station ID. So I'm just going to open up LeafPad and write target equals this MAC address, and okay, no targets have been there right now. Okay, so we got a MAC address, right? And the probe is deceiver. Now the probe means basically when my phone is searching for my Wi-Fi router, it sends probe to the air that, okay, hi, I was connected to the access point called deceiver. Any of you are deceiver, so I need to connect to you. This message is also captured by aerodump, so we already know that deceiver is going to be the SSID. We already know that. So now we got the MAC address of my phone. We are just going to stop this process right now. We got the MAC address of my phone. Just let me say this is target access point and this is target station, and the MAC address is this one. So now we will run this command again, but we will also write this down. So let me just delete everything that was there in the directory from my previous practices. Anyways, I just deleted every one of them. Okay, now what I'm going to do is write this down, right? Okay, so let's just write it down. Okay, I have already given that. Write deceiver, maybe just DEC. What's the problem in that? No problem. So I'm writing this. Okay, not just now. I do not want lots of packets in there. I just want the main important ones. But before that, let me just see if I can import here my word list, which was there, right? So WPA2 was my folder, and there is the list. Let's see if I can import that. All right. Yes, I just imported it. If I open this up, just run this file, why not? Let's do full screen there. Okay, so open, just display, and is there James Bond 007? Yes, there is James Bond 007, right? So I have this list, the same list which I used in a previous demonstration. So now let's go ahead and write this, but before that we are going to deauthenticate my phone from the router. Now already I have shown you in a previous slide that the tool we use to do that is Air Replay NG, but just let me explain how Air Replay NG deauthenticates the supplicant and the authenticator. Well, what happens in a deauthentication attack is the tool Air Replay NG clones my phone's or the supplicant's MAC address and tells the router that, hey, I am currently connected to you and I need to deauthenticate myself from you. And consecutively, it also clones the router's MAC address and sends to my phone, or in this case the victim supplicant, that hey, I am the router and I need you to deauthenticate yourself from my services. So by sending this message, the router and the phone, or my phone, or in this case the victim's phone, is disconnected. So that's how, when the deauthentication process stops, my phone or the victim phone will try to connect to the Wi-Fi router again, and then the handshake will happen as well. What we are going to do is we are going to capture that handshake right away and perform a brute force attack on that handshakes. So to do a deauthentication process, it's basically air replay ng -- deauth -a, and here we are going to provide the target access point MAC address and -c, then the station's MAC address. After we have, okay, they are basically the same. There is some problem in copying, I guess. Copy and paste. Okay, now it's okay. And lastly, we need to give the interface, which is WLAN 0 mon. Now before running this, we also want to run this process, so it will instantly deauthenticate and capture the process. And I do not want to actually capture a lot of packets, so it's hard for even me to search for the packets that I want to show you in Wireshark. Let's start this process. Enter and enter. Okay, the deauthentications have been sent, and let's wait for the capture here. Okay, you can see the WPA handshake popped up, and we are just going to stop the process. So when ARO shows a WPA handshake at the top, that means we have the handshake. So let's just check if the handshake is valid. I'm going to use cow patty for that, and just say cow patty -c, and I'm going to give dec.cap. Okay, there is a syntax error, I guess. Must apply. Okay. To the message. What is going on? I guess we have to dec01.cap, right? Okay. Okay, now as we have verified that we have a valid handshake, I'm just going to show you what exactly happened in the handshake. So Wireshark, we are going to use Wireshark to do this, and we are going to open, the cap file. Now you can see there is a lot of packets, and because I instantly started the deauthentication, as soon as I started sniffing the packets out, we can see all of the packets here are deauthentication packets. You can see one time it's sending from Motorola, like one time it's sending being my Motorola device, one time it's sending being my router device, again it's sending being by cloning a Motorola device, and again it's going to send it with by cloning my router's MAC address. Now as the authentication packets are done, we are going to go and search for EAPOL packets where the handshakes actually occurred. So this is a very clear one. As you can see, there are 4 messages, 1 out of 4, 2 out of 4, 3 out of 4, and 4 out of 4. And if I open one of them, you can see everything that I have told you. Now, there is the WPA key nonce, and remember, if you remember from the previous tutorials and slides, that in the first message the authenticator sends a nonce value to the supplicant. Well, in the first message this is going to be the nonce, or the a nonce value. Alright, so, and there is the MIC here, which is basically 0, because on the first message there is no message integrity codes going on within the shared packets, right? So that is supposed to be on the second message. So let's go over to the second message and see. Now this second message's WPA key nonce is going to be the supplicant nonce or the nonce value that my phone in this case sent to the router. And you can also see that there is in fact MIC or Michael Message Integrity Code present, and this MIC has been generated by using the first 16 bytes of the pairway transient key, which is also called the key confirmation key for the HMAC SHA-1 operation. You can actually see that it's a HMAC SHA-1 operation somewhere here. So you can see that it's an HMAC SHA-1 operation and it's saying MIC. So in the third message there should be an install the keys order from the router to the supplicant, and if you just click on the key information, you can see that the install is being set to 1 or set to a positive, which means that the router has ordered my phone here to go ahead and install the keys. Okay, so that's the way it is on the third message. And the fourth message is basically acknowledgement from my phone to the router that is saying that okay, we are now ready to connect and share data. So we have the 4 messages of the handshake, and now we are going to go ahead in AirCrackNG and crack them. So to do that, we have to first check what is the exact name of the cap file. So we already know it's dec-01.cap. So all we are going to do is launch aircrackng. By the way, just remember that for this attack to work, we do not need our Wi-Fi adapter or the Wi-Fi adapter being in monitor mode. So this is a completely offline attack. So we are going to go to aircrackng, and then we are going to specify the capture file, which is going to be dec-01.cap and minus -w, which means the word list file, and the word list file is going to be list.txt. all right, so list.txt. let's see what happens. It didn't even take a lot of time at all. So my key has been found in basically 0 seconds, a little bit more than that, but 0 seconds. You can see the speed right here. So you can also see that 52.17% of the word list has been scanned, and the key found was on the 52%. So that's how the key for my Wi-Fi router is cracked. So now you exactly know how to crack a Wi-Fi password and the story behind the scenes of what happens in a Wi-Fi cracking attempt. Alright?